we will go ahead and get started talking about radical expressions, okay? Well, let's talk about radicals. What are radicals? So typically an operation has an inverse, right? We talked about that a little bit yesterday, but addition has subtraction, right? They are inverse operations. They cancel each other out. You add 2, you take away 2. Same is true with multiplication and division, right? You can always undo multiplication by dividing. You can undo division by multiplication. There's exponential terms and logarithms, so something like 2 to the x power and log base 2 of x, okay? Maybe not x, let me not put a variable there. Let me just put a blank. Okay, so they cancel each other out. And then there's exponential terms like x squared or x to the 4th power or 3rd power. I'm just tapping buttons here. And the nth root. Okay, or the square root, the 4th root. Okay, so this is what we're talking about, radicals, the inverse of exponential terms. Okay, and then there's some terminology. Maybe it's good to know this, maybe not. I've never found it very useful to know all these terms, but I'll review them really quickly. We have the index. That one's actually a pretty good one to know if you know any of them. That is the index, the root, right? So if you're looking for the square root, it's a 2. If you're looking for the cube root, it's a 3. The 4th root, it's a 4, and so on. Okay, this a to the m part right here is called the radicand. Okay. And the m inside of there is called just the exponent or the power, which we knew that already. And finally, this thing right here is the radical. Okay, so there's the radical, the index, the radicand, and then of course the power and all that. Okay, so again, maybe it's useful to know these terms, maybe not. Radical and index are pretty good to know. All right, and so I'm just going to put this up here for a second and say you should memorize some of these. Actually, I would say all the ones that are listed here you should memorize. So in other words, you want to learn the perfect squares. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3, and so on, right? So you want to learn those. They're really helpful just to have them memorized if you don't already know. And I find memorizing up to 15 is pretty good. So 225, it's good. Let's now actually simplify some radicals. Okay, so we have the square root of 16x to the 8th. Okay, look at this as 2 different problems. Okay, this is the square root of 16 times the square root of x to the 8th. Okay, square root of 16, square root of x to the 8th. They're the same thing. And if you look at it this way, it's easier to see. The square root of 16 is 4. Hopefully we have that memorized. Why is it 4? Because if you break down 16, it's 4 times 4, right? 4 squared. And if you think about 16 as 4 squared, well, guess what? We just said that these are inverses, right? So remember, there's an understood 2 right here. If there's no number there, understand that that is an understood 2. The radical and the power cancel each other out, and they leave you with the 4. Okay, so that's how you should be thinking about this. That's radical. That square root cancels out the square and leaves you with the number inside. Now, same thing is pretty true with this x to the 8th. Okay, so x to the 8th and a square root. Well, something similar is going to happen here, right? So let me actually go back to the 4 squared here. And we said, okay, well, the understood 2 is there. So this and this cancel out. Well, they kind of canceled out, right? What is 4 really? If you had to give 4 an exponent, it'd be 4 to the first power, right? Okay, and so it's 4 to the first power. Well, one way you may see us getting a 1 for that exponent is dividing this by this. You divide the exponent by the index. Okay, and so if that happens, sure, that's easy. Let's do the same thing here. 8 divided by 2 is 4. So that's going to leave me with x to the 4th. So there's our general rule. Okay, our general rule. If you have a number that breaks down easily, then do that. Okay, so we didn't have to think too hard about that one. But if something has an exponent on it, divide that exponent by the index, whether it's given to you or understood, and that will simplify your problem for you. Okay, so that was a lot of talking about one mostly simple problem. Let's do another one. Okay, so this is the cube root of p to the 5th power. Okay, and if I try to divide that one, I run into a problem, right? It's not a whole number, okay? So what you should do to think about that p to the 5th power is think about it as p multiplied times itself 5 times. Okay, because I'm interested in the 3rd power, right? The 3rd power, groups of 3. Okay, if I group these 3 together, that's p to the 3rd power. I group those together, that's p to the 2nd power. Okay, so that group of 3 is how I should use that group of 3 to break up this. Well, if I break it up, I can always break it into 2 pieces. Like in the previous problem. Okay, so why would I do that? Because that's going to divide evenly. Okay, so 3 divided by 3 will give me 1, so p to the 1st power. 2 divided by 3 is just going to be 2/3, so I'm actually going to leave it as the cube root of p squared. Okay, so there we go. I simplified it. I took out a group of 3, divide that by 3, so I brought the p to the outside. And then I couldn't do anything with that p squared, so I just left it inside. All right, so again, the rule still applies. 5 divided by 3 is 5/3. You could also say that's 1 and 2/3, right? 1 and 2/3. So there's my 1, there's my 2/3. So here's some rules dealing with radicals. We won't do too much about them, but notice that they're actually the same thing, pretty much the same thing as the exponent rules, okay? And there's a reason for that. So if you have multiplication, well, actually we used these rules already, at least this one we used. This one right here we can use if we wanted to by breaking it up into fractions, all right, numerator and denominator. And this one just says you can factor things out. Okay, another thing to talk about, and this is really important. The reason why there's a relationship between the rules for exponents and the rules for radicals is because radicals are just exponents. That's all they are. They are exponents that are fractions. And so you see it right here, a to the m, the nth root of that is the same thing as a to the m over n. Let me plug in numbers to make that a little bit more concrete. Let's say you had the 4th root, let's say the square root. We have the square root of 3 to the 5th power. Okay, well, that's the same thing. We just talked about dividing exponents, right? You divide that 5 by 2 to the 5/2 power. Okay, so we did that in the last few examples. We just didn't necessarily write it that way. But this is how it works, right? They're the same thing. And so if you see something like 5 to the 1/8 power, understand that that's just simply the 8th root of 5. All right, so here's a problem. 8 to the 2/3 power. Okay, so we can write that a few different ways. We could say that that is the cube root of 8 squared. We also could write this as the cube root of 8 squared. And really, it depends on what allows you to simplify it easier. Okay, there's different ways to simplify this, and you'll get the same answer either way. Remember, the third root of 8, if you look back way in the beginning, we talked about that list of roots to memorize. The 2 to the third power is 8. 2 to the third power is 8. So this is really a 2. The cube root of 8 is 2. And so that's really just 2 squared. 2 squared is 4. That's one way to look at it. Another way to look at it, let's say that let me just rewrite it here. Well, 8 is 2/3, or 2 to the third power. And remember, the cube root will cancel out with a cube to leave you with 2 squared. Okay, that's another way to look at it. Same idea. You could do 8 squared first and get 64. Now that one's a little less obvious. What's the cube root of 64? Maybe you have that memorized. Maybe not. Let's make a factor tree. We're looking for groups of 3 this time. 64 is 8 times 8. 2 times 4. 2 is a prime number. 2 times 4. 2 is a prime number. 2 times 2. 2 times 2. So that's 6 2s. All right, groups of 3. There's one. That comes out of the radical. There's another. It comes out of the radical. There's nothing left, right, to put back in the radical. So there's no more radical. And what's 2 times 2? Yeah, there you go. It's 4 again. All right, so a lot of ways to look at it. Let me do one more way. It's my favorite way to look at it. So we have 8 to the 2/3 power. We just said that 8 is the same thing as 2 to the third power. So I'll write it as 2 to the third raised to the 2/3 power. Our laws of exponents say whenever you have this situation where you have an exponent raised to another exponent, you just multiply them together. So 3 times 2/3, the 3's would cancel, leaving me with a 2. And 2 squared is 4. Okay, anyway. Okay, let's use what we know to simplify this expression here. Okay, so we did say that if you have a fraction with a radical on the top and on the bottom, what you could do is write it as one radical. And the reason why I wanted to do that is because I thought that this looked like it was something I could simplify. Okay, and so x to the third power over x squared. Remember, when you divide, the law of exponents say you subtract the exponents, of course, if the base is the same. And 3 minus 2 is 1, so this is the fourth root of x to the first power, which is one way to have it simplified. Or I could even write that as x to the 1/4 power. Remember, these two statements are equivalent. All right, so let's see if we can simplify this one relatively quickly. Sixth root of 128 x 12 y 13. All right, so let's think about that. 128, let's break that down. That's 2 times 64. This is 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. 1, 2, 3, 4, 5, 6, 7. 7 2s. Okay. And so I'm looking for groups of sixes. Group of 6 2s right there. So that's 1 2 that's going to come out. I do have a 2 left underneath. Okay, so that takes care of the 128. Okay, this is easy enough. X to the 12th. 12 divided by 6 is 2, so x squared will come out. So that divided the 12 by 6. Okay, y to the 13th. Okay, well, 13 is a little bit big, so we're going to have a remainder. But what is 13? Well, that's y to the 12th times y to the 1st. Okay, so this one will divide evenly with the 6. If I divide that 12 by 6, I get y squared. And I have this y left over. So let me rewrite that. 2x squared, y squared, the square root of 2y. All right, so let's rationalize the denominator. So this question's a little different. It's a little bit off topic, but I didn't know where else to put it. So let's talk about this. This is a question you'll see on the ALEX test. You have the square root of 10 minus the square root of 5 on the denominator, okay, in the denominator. And whenever a question says to rationalize the denominator, that means cancel out any radicals you see in the bottom, okay? And so if it looks like this, the best thing to do is to multiply by the conjugate, okay? And what that means is look at the denominator, look at the sign in the middle, change that sign and multiply the top and the bottom by that. Okay, so I got the square root of 10 plus the square root of 5, again, by looking at the denominator and changing the middle sign. It just so happened to match the top, but that's not always going to be the case. Okay, so remember, this is going to be something where we distribute. Okay. So distribute the 10. Square root of 10 times square root of 10 is just 10. Square root of 10 times square root of 5 is the square root of 50. Square root of 5 times the square root of 10, the square root of 50. Square root of 5 times the square root of 5 is 5. All right, and then in the denominator, square root of 10 times 10, square root of 10 is 10. Square root of 10 times square root of 5, square root of 50. Negative square root of 5 times square root of 10 is negative square root of 50. Negative square root of 5 times square root of 5 is negative 5. So there we go. Now notice what happens in the denominator. Those two will cancel out. All right, combine like terms. So top there's 10 and 5. That'll be 15. I have 2 square root of 50, so 2 square root of 50. 10 minus 5 is 5. Okay, and now I want to see if I can break down the square root of 50. That's not too hard. Square root of 50 is the same thing as 25 times 2. Square root of 25 times 2. Square root of 25 is 5. So 5, the square root of 2 is the 50. When you write it like this, you can see that those can be multiplied together to give you 10. And then divide. 15 divided by 5 is 3. 10 divided by 5 is 2. So my final answer here will be 3 plus 2 square root of 2. Okay, so you'll practice that at some point. Okay, and that's probably the last one we'll do.